So let's talk about something we see pretty much every single day, but maybe don't really think about all that much. The sun. It's right there, our neighborhood star, and it's the source of basically all the energy on our planet. Without it, well, life just wouldn't be a thing. So I think it's time we take a closer look.
To really get a handle on just how important it is, let's do a little thought experiment. It's a bit dramatic, but stick with me. What would happen if, right now, the sun just poof, vanished? Well, the answer is pretty bleak. Our planet would instantly be thrown into total darkness, and without that constant warmth, the surface would freeze over so fast, turning Earth into this desolate, barren ice world. It's a chilling thought, right? But it perfectly shows how completely we depend on that star.
Now, of course, long before we understood the science of it all, people have always been totally fascinated by the sun. I mean, it was this source of incredible wonder and power, and for a lot of cultures, even worship.
Take Hindu mythology, for instance. To them, the sun wasn't just a big ball of hot gas. It was a literal god named Surya who would ride across the sky every single day in this magnificent chariot. And you can see why, right? It's this beautiful, powerful story to explain the rhythm of day and night.
So you've got these two totally different ways of looking at the same thing. On one hand, you have this idea of a powerful god, a conscious being. And on the other, you have the scientific view, the sun as a natural object, a gigantic star fueled by this incredible engine deep inside it. So let's peel back the layers and see how that engine actually works.
Deep down in the heart of the sun, there's a process going on that is so powerful it's been running for over 4.5 billion years, and it's the source of every single photon of light and every bit of heat that we get.
And that process? It's called nuclear fusion. Inside the sun's core, the pressure and the heat are just so intense, we're talking millions of degrees, that they literally force hydrogen atoms to slam together and create helium. And when that happens, a tiny bit of their mass vanishes and is converted into a huge amount of energy. It's basically Einstein's E equals mc squared in action on a massive scale. The sun is, for all intents and purposes, a giant self-powering nuclear reactor in the sky.
Okay, so once that energy is created, it doesn't just stay put. It starts on this absolutely incredible journey, all the way from the sun's core, through space, to us, right here on Earth. And we're not talking a short trip around the block. That energy has to cross this vast, empty vacuum of space, a distance of about 150 million kilometers. That's roughly 93 million miles.
But here's the wild part. Even with that enormous distance, light travels so incredibly fast that the whole journey only takes about 8 minutes and 20 seconds. Just think about that for a second. The sunlight that you can feel on your skin right now, it actually left the sun over 8 minutes ago. You're feeling the past.
So we know it's a long journey, but just how much energy actually makes it all the way here? I mean, what's the payload? The numbers, and I'm not kidding, are almost impossible to wrap your head around. Let's just try to get a sense of the scale. We'll start small, or what sounds small. How much solar energy do you think our planet gets in a single second? Okay, the number is 1.74 times 10 to the 17th power joules. Now that's a huge number, but it's just a number, right? What does that actually mean in the real world?
Let me put it this way. The solar energy that hits the Earth in just 1 second is enough to power our entire planet's electricity needs for several years. All of it. Every second. Just, wow.
Okay, so that was 1 second. What happens when we scale that up? What about the total amount of energy that arrives over one full day?
The number just gets even more ridiculous. 1.5 times 10 to the 22nd joules. Again, it's just a string of digits until you really put it into context.
So get this. The energy that our planet gets from the sun in 1 day is enough to power all of human civilization, every single city, every factory, every car, every home, for millions of years. It is an absolutely mind-bending amount of power just given to us for free every single day.
Okay, so this ocean of energy arrives constantly. But so what? What does it actually do? Well, it becomes the invisible engine that drives just about every single thing that happens on our planet.
I mean, it all starts with the food we eat. Plants take in that sunlight, we all learned about it in school, photosynthesis, and they turn it into energy. Then animals eat those plants, and other animals eat them. Every single living thing, you and me included, is basically a solar-powered machine.
And it doesn't even stop there.
The sun is what drives our weather, our climate. It powers the water cycle that gives us rain and rivers. It keeps the whole planet at a stable, livable temperature. Heck, even the fossil fuels we dig up, coal, oil, that's all just ancient sunlight that was stored away by plants millions and millions of years ago.
So, after hearing all that, you've got to be thinking, wow, our sun must be pretty special, right? I mean, is it some kind of 1 in a billion, uniquely perfect star out there in the cosmos?
Well, the surprising answer is no, not really. Almost every one of those little pinpricks of light you see in the night sky is a massive fusion engine, just like our sun. The crucial difference isn't about what the sun is, but where it is. It just happens to be the only star close enough for us to feel its energy in a big way. And that, right there, is the key. That's the whole secret. There are billions upon billions of stars out there, all generating these insane amounts of energy. But for a planet like ours, location is everything. Only our sun is in that Goldilocks position, close enough to provide the light and warmth needed for life to even get started, let alone thrive.
And that leaves us with this really cool, kind of humbling final thought. On a cosmic scale, our sun is just another ordinary yellow dwarf star in a quiet corner of the galaxy. It's not special at all. But from our point of view, right here on this little blue rock, that one ordinary star, well, for us, it's everything.